problems. And yeah, if you like content like this, please remember to subscribe. And other than that, you see that we have solved 39 problems so far, and let's see how many more problems we can solve in the next hour or so. So yeah, let's start. Let's start with problem 40. And as we do that, let's create a new Jupyter notebook. We will call this problem 40 and problem 40, and let's copy the problem first. What the hell? Problem 40, and this is the problem. I believe I will have to do this, and this is a subscript. This is a subscript. Oh god, like that. That's a subscript. That's a subscript. Subscript. Okay, so let's TH should not be italics. DN anything else? 12th digit of the fractional part is 1. Okay, let's read the problem now. An irrational decimal fraction is created by concatenating the positive integers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, okay. 13, 14, blah blah blah. Okay, so we create this. It can be seen that the 12th digit of the fractional part is 1. So this red thing over here, 1, 2, 3, 4, okay, 9, 10, 11, 12. Okay, so that's why that's the 12th digit. Okay, is 1. If Dn represents the nth digit, okay, of the fractional part, find the value of the following expression. So we need to find D10, D100, D1000, D10,000, 100,000, and a million. I think this is a million. Yeah, that's a million. Okay. The first thing that comes to mind is brute force. It's just easy to brute force this. And in Python, this should not be a very difficult thing to do, to brute force. But let's try to do something a little more interesting. Let's try to figure out whether we need to brute force or not. Okay, let's start with brute force. Let's do the brute force solution. Okay, what is the brute force solution? The brute force solution is very simple. We take okay, let me take out my iPad. Let me take out my iPad and let's talk about the brute force solution. Okay, so what's the brute force solution? Sure. So we're going to start with a number, let's say 1, then 2, then 3, and so on. So we are going to start with and all the way to say 12, 13, 14, and so on. And at each point, so we are going to do it in a streaming fashion. So we have the numbers 1, 2, 3, 4, and so on. It will go into this we'll think of as a stream. Okay, and at one point we will have the number, let's say 12, which is somewhere over here, 12 and 13 and so on. So this is going to be a current number, and then so this is going to be a constant stream. So 11, 10, 9, 8, and so on. So these things have already passed. This is the current number under consideration, and this one will be 13, 14, 15, 16, and so on. Okay, so that's and at this point we want to keep an index I. That is what character is it? So is this the 13th, 14th, and so on. So as a new number comes in, we are going to increment it by the length of this. So that's, and depending upon where we get the nth number, we will just find it. Okay, so that's the idea. And depending upon which numbers we are interested in, we will just add and then concatenate. So that's the quote-unquote brute force idea. So this is interesting in the sense that it is a way in which a lot of streaming platforms work. So if you are looking at Apache Beam, or if you're looking at Spark streaming or something like that, then Kafka's streaming platform, then something like this would be a solution. This is a quote-unquote big data solution. Big data solutions are not always the fastest, but it is going to be a solution where the memory is not going to be an issue. So you can go on and on forever, and then you should still be okay. So memory footprint is going to be very low. The computational footprint is going to be very high. So that's something that's worth keeping in mind. If you want to not do that, then you have to do some calculations, and that's not what we are going to try to do in this brute force solution. Okay, so having said that, let's try this. Let's try this interesting solution, and let's see whether we can get it done in this particular way. Okay, let me increase the size a little bit so that I have a little more space to work with. But this is going to be the idea. All right, so let me turn this off. Oh shit, I shouldn't have turned this off. Okay, I'm trying to make it so that it turns off, but I still have the picture. Okay, so that would do it. Right. Turn off my pencil. It's turned off. Okay, let's try to implement this. So we need an iterator, right? So okay. Okay. What we want to do is we want to create a function that will give us the current value of this as well as the index. So it's just a number. It'll take an n, and it is going to create an iterator. So this looks like a very strange function, but we will add things to it. So what does this function do? We can create a for loop. So five, let's say, is going to give you 0, 1, 2, 3, 4. We don't want it starting from 0. So we want it to start from 1, and we will go all the way to n plus 1. Okay, so this is going to give you 1, 2, 3, 4, 5. So but it's going to give it to you in, so this is an iterator. It'll give you things one at a time, so you can inspect it one at a time. But at this point, you not only want to provide I, okay, you also want to provide the index associated with this value I. So how do you do it? Let's try something. I'll see if this works. If it doesn't work, then we'll have to convert it into a class. Okay, pointer, and then okay. So this seems to work. If we go all the way up to let's say 12, Okay, 12 is 14, so it's incrementing. So 10 is 10, 11 is 12, so the first element of 11 is 12, the second element is 13, then this becomes 14, and this becomes 15, and so on. Okay, so that's the idea. We are getting this value 12, okay, right here, as well as the index I is 14, and we might also say what is it's 14 and 15, right? 14 and okay, so let's see. So this goes from 1, the pointer is 1, and the end pointer is 1. What this means is that number 10, the pointer of 1 is 10, the pointer of the last digit is 11. So if you want the nth digit, so let's say we go all the way up to 50, 150, let's say we go all the way up to 150. Then what happens is that 127 is in the 271th position. Okay, the 1 in the 127 is in the 271th position, this is in the 272nd position, and this is in the 273rd position. Okay, so if you want a particular item, then you want to see whether it is between this and this both inclusive, so that way you can figure out which one, whether this particular number is something that you want to get a character from. The other thing that you may want to do is to say that, okay, this is going to be a string. I'm going to return a string, and the reason for that is very simple. I want to extract individual elements from this particular number. Okay, so that's the idea. Okay, so now that we have this function, so now that we have this function, what we want to do is to see whether we are able to get the nth value. So let's say we want to get the 100th value. Okay, equals, let's go from 1, 10 and 100, and see whether we are able to get all the values in here or not. Okay, so okay, for n in n list, we will go to 1,000,000. Okay, so let's just write a for loop. V1 as start and end in this function, and we are going to say we are going to go all the way to 1,000,000. Okay, and if we find everything that's there in end list, then we are going to just stop. Okay, so like that. Okay, so what we are going to do over here is we are going to check whether start and end are within a certain value of end list. Okay, so currently we are checking for 1. Okay, if we find 1, we will put it in end found, and then we'll increase this. If it reaches 100, then we will say that, and if it finds 100, then we will say that okay, we found what we wanted to find, and then we are going to break out. So what we are going to say is if n found, the length of n found is equal to the length of n list, then break. Okay, this is the terminating condition. Currently we are trying to find let's put it outside. To find equals n list current n. Okay, and let's just stop the moment we find the first one, and then we will continue once we have that. So if start is greater than equal to find if this is greater than equal to this, and end is less than equal to find. If that is the condition, print let's print v1, let's print start, and let's print stop, and end, and okay, so I should actually print it properly. Okay, start and stop, end, end, and we have located the value to find, right? Find. And if we have found it, we need to add it to nfound. Hence let's append everything. Let's append v1, let's append start, and let's append end. Let's append everything. And let us also append to find. That's that one. Okay, just to check that we have found everything, and let's see whether this works. Okay, so it just gives us one thing, even though nList is 3. Is it going through everything and not giving us the results? Or okay, so let's print v1 start and end, and let's limit ourselves to 20 over here. 20. Oh, okay, so it's able to go through everything, but it is not able to identify the fact that because we haven't updated to find. Okay, equals and found, like that. Okay, there's a problem. No, nList. So it's come over here. This is true, and end is 11 is less than equal to 2 find. Oh, let's make sure that we have the proper brackets. Is that the problem? That is not the problem. I'm just a moron, that's all. Okay, so I don't need to print this anymore. Let's go all the way up to 100. Okay, so we are able to find 1, 10, and 100, and we just need to go all the way up to, oh, okay. So the next thing we have to find out is if we are at 100, right? So this is the 100th item. This is the 101 first item. Let's go to 1000 and 10,000, like that. Oh, because 10,000. Okay, now this is interesting. If we want to find 1000, then we need to figure out which value it is. So in this case, it's 9998 is this, 9999 is this, and this one over here is 10,000. Okay, so we need to extract the 7 from there. Okay, so how do we do that? We take this, we take the first element, this one, and we take this and subtract this, the first one, from here, and we will see which one is which character in this range is the one that is what we want to look at. Okay, so this one over here is to find, so we want to subtract nth value equals, we want to subtract from to find, that's the last value over here. From here we want to subtract the start. Okay, and this is going to give us the nth character that we want to extract. So we have v1, the nth character is to extract is that. Okay, so let's also put TQD in. Okay. to extract is that. All right. So the first one we extract 1, the second one we extract 1, the third one we extract 5, the fourth one we extract 3. Is it really correct? Apparently. The fifth one we extract 7 because it is this value here. Okay, so let's go all the way. This is 10,000. One, 10, 100, 1,000, 10,000, 100,000, and a million. That's what we are looking for. One, 2, 3, 4, 5, 6, 7. Do we have 7? 1, 2, 3, 4, 5, 6. We don't have. We need one more 0. 1, 2, 3, 4, 5, 6, 7. We have 7 values. Okay. Okay, so we have the extracted numbers. These are the numbers that are to be extracted, I believe, and we want the product of all of these things. So n found happens to be all of this. We don't care about all of this. We just care about int to extract, right? So n found will be what the hell? Like that. Okay, and product of all of this is 210. Let's see if this is the answer. Okay, so what we have seen is we have solved this problem using a big data architecture, and it looks like a pretty simple thing to do. It's not a very complicated thing. So so much for today. Let's catch up next time. Bye bye.